Yes, welcome. Welcome to the session on artificial intelligence, AI, the tools and its application. Now, this is the future power. Yeah. So this session will be presented by Dr. Venugopal, Kanavillil, and okay. So this is the online program which we have launched. We have courses, UG as well as PG courses. Now I'm going to talk about the BBA course, that's Bachelor of Business Administration. The eligibility criteria is a 12 certificate, a diploma, or if you're a UG, you want to change, yes, you can. This is a 3-year program, 3-year course, and the various job titles that you can start off after completion of this course are few of them. I'm just naming: finance manager, business administrator, human resource manager, research development manager, business consultant, information systems manager, marketing manager, business analyst, project manager, strategist, market analyst, so on. There are more. So I'm just naming a few. So you can start off with that. I have my colleague also here with me, Ms. Srikala. She will brief you about the BCA advantage. Yeah. She is a program coordinator for BCA, MCA online programs. She's an electronics engineer graduate, specialized in applied electronics. She holds a management degree in operations marketing. She has 3 years of academic experience, and she's deeply passionate about industrial automation. Over to you, Ms. Srikala, for the BCA presentation, please.
Yeah, thank you, Shipra. So thank you for the brief introduction. So I hope I am audible. Yeah. So very good morning, everyone. Yeah. So through our new initiative, Amrita AHEAD, we are launching our online BCA program. So I'll be conveying some of the key highlights of the program, how this particular program is different and unique from others. That is what the differentiation factor is, what I want to convey to you. Yeah. So the main highlight, the key highlight is, at your comforts, you can earn a UGC recognized degree from India's 4th best university, ranked by National Institute of Ranking Framework, NIRF. And now this degree is equivalent to any other UGC approved degrees in India. And earning this degree with this, you are eligible to apply for both government, non-government sectors examination, as well as you can go abroad, you can pursue your studies there, you can do your future prospectus, you can continue your future prospectus abroad. Yes, anything. So whatever a physical degree offers to you, UGC recognized offline degree offers to you, this very degree is equivalent to that. Okay. And the next very key highlight of this program is it's applicable for both freshers as well as the experienced people. So also this offers enough flexibility to you in terms of pace of completion. That is very important to note. Yes. And so I'll explain it in brief. So a person can complete it in a minimum year, 3 years, and span it to 6 years. You will earn the same degree. That is the most beautiful thing about this degree, that it allows the target audience to complete it at your own flexible timing. And next, so coming to the next, in terms of employability, so those who have finished their schooling, who are aspiring to be technology experts, so this is the best choice that you can go for. Means, why you can trust us is that in terms of employability, Amrita University's dedicated placement cell, placement agency, CIR, corporate relationship agency, is delivering excellent track records of 100% placement for over decades. Okay. And many of our alumni, almost all our alumni, because we are always for almost 2 decades, we are delivering 100% placement records for our students. So almost all our alumni are working with leading industries around the globe. To name some industries: Google, Microsoft, Intel, TCS, Infosys, and wherever and whatnot. Everywhere you can find an Amrita alumni there. Yes. So that is the way the corporate industry relationship, that is our placement agency, will train you, will groom you to the professional status. So once you enroll as an Amrita student, we'll be grooming you from the day one to become a professional. And in BCA, of course, a technology professional. Yeah. And so throughout this program, you can expect those alumni support as well. So the main thing to note here is 360-degree placement assistance is offered by our placement agency. Now, coming to the uniqueness of the courses, you'll be excited to know about the courses, right? Yeah, yes. See, some of the statistics I just went through from Gartner.com, and then so like data crunch. I was stumbled to like kind of note the statistics. There is about 500,000 unmet demand for AI and data professionals around the world, and I could see that there are over more than 2.5 lakhs of demand for Python programmers in India. So but we are producing more graduates to meet the demand. Then why is it not getting met? So there is the trick of this program. So through this program, we are kind of trying to bridge that gap between the industry and the academia. So now you will be aware that we are at the very neck of Industry 4.0, where artificial intelligence, cloud computing, and data science rules the world, rules the industries. So machines are becoming more intelligent than man. So we should be really equip ourselves to like program our machines like that, to assemble, to make the machines intelligent. So this particular program are actually designed to bridge that very gap. We provide through this program what exactly the industry standards requires. What they say that we give, that is what we are doing through this program. And why, you may ask, how? Yes, I have an answer for that too, because the curriculum of this program, the syllabus of this program didn't come up in a day, but it was designed, the course methodology was designed after several discussions with the industry experts, with the data research lab scientists, after several discussions and revisions with the industry experts, and also the subject matters experts around the globe, around the universities. We have tried to associate with them. Then we have come with a particular syllabus that delivers what cutting edge technology the industry demands, how they hire. And to note, it is very important to note that industries are today, the industry is very specific in hiring. They with the intrusion of industry 4.0, what is happening means industries are no more generic. They are kind of like, they have specific requirements for this particular role. As Shipra rightly mentioned, a lot of roles. For the project management role, you need to know track project, schedule project in this and this tool. They mentioned that very clearly. So you have to be kind of like equipped to face that kind of like thing, what industry exactly needs. So that is how we prepare you for this course. And apart from that, you could see that like some of the companies, especially, so most of you, a lot of you will be passionate about networking, a lot of you will be passionate about configuring a cloud and working with its servers, etc. So this course also offers you another attractiveness. Why? Because we have a lot of associations with industry, people like Cisco, Amazon, and Microsoft. You can tell that we are trusted members of them. We have an education agency of them in Amrita. So what we do is, we kind of like offer you free training for the certification courses. You could pick certification courses as electives, and trained faculty will be certified, or trained faculty will be like kind of teaching you those courses and preparing you for the certification examination. Okay, so somebody who's interested in data and science and analytics streams can choose that certification from Cisco, Amazon, Microsoft, etc. And somebody who is interested in cybersecurity can go in that track and choose electives, certification courses as electives of particular that track. So these are all, you could see the industry relevant certifications: data science, systems and networks, cybersecurity, app and full stack development, virtual and augmented reality, cloud computing. So these are all pillars of industry 4.0. So we are kind of trying to give elective certification courses, okay, which are industrially valid courses in these streams as electives. So that is one of the main uniqueness of this program and the course methodology that we offers. And also a lot more electives in every semesters we are offering in these streams, which are the pillars of industry 4.0, what exactly industry asks for. Okay. And apart from that, we have training for Cisco certified network associate. If you want to be like an ERP switching routing engineer, then you can go for this kind of courses. If you're really interested in security kind of thing, if you want to do a security kind of courses, you can choose electives in this track which are offered by the Easy Council. Apart from this, we have lot more courses to be included from Microsoft, that is in terms of Azure cloud compute, Azure cloud configuration and the server configuration, etc. We also have courses from CompTIA, IBM, etc. And apart from this, I already told you, industry experts are a part of this program, and they also will be kind of like assisting you to do a lot more projects also. So these are some of the key highlights of the program that I could share about BCA. So I think everyone have understood this one. Now, thank you for this opportunity, everyone. It's nice meeting you all. Yeah, and I'm moving to Ms. Shipra to please introduce the speaker, the esteemed speaker, Dr. Venugopal. Yes, Shipra, you may please continue. Thank you. Yeah.
Thank you so much, Ms. Srikala.
Yeah, thank you.
That was a lot of, that was a very valuable information that you provided. And before I introduce Dr. Venugopal, we are live on Facebook. I just got a message, and yes, we are live. We are going live. We are right now live on Facebook. So you can watch us on Facebook also. And yes, now to the main presenter, who we all have been waiting, Dr. Venugopal Kanavillil. Now, he serves as an associate professor of computer science at Amrita Vidyapeetham University. He has a bachelor's in electrical engineering from NIT Calicut. He has a master's in electrical engineering from IISc Bengaluru, and also a doctorate in computer science from IISc Bengaluru. Following his doctorate, he has been associated with the information technology sector for 26 years, working on industry solutions for retail, telecom, banking and financial services, and energy and utilities business domain for domestic as well as international customers. Now, he has previously served as a group manager at IBM in the Cognitive Business Division of the Global Business Services BU. He has also held senior roles at reputed IT companies, HP, that's Hewlett Packard, Toshiba Software, and Wipro Technologies. Thank you, Dr. Venugopal, for being a part of the session, for being the main presenter, for providing us with the information on AI. Over to you, sir.
Thank you, Shipra, madam. I hope you can hear me. I will just try sharing my desktop now before I get into, while I'm trying to share the desktop, I'll also give you a kind of a background about myself, and also a couple of minutes as a preamble. I think Srikala madam had just asked me to just flash a couple of slides. I think she and Shipra madam have already shared this, but I will just do it again. So just let me know if my desktop is visible to you. So let me first start with the slides. Okay. So a couple of words about myself. As Shipra madam have said, I have a total of about 26 years of industry experience, and post that I have been into academics. I was last a professor of computer science at Presidency University. And my industry experience, some of the prominent companies I worked with are, as Shipra madam has reiterated, IBM. I was a group manager in the cognitive solutions group. All of you must have heard about the Watson platform. Can I get a reaction? Have you heard about Watson? Any of you? Okay. By the way, Watson was, as you know, as some of you follow the tech news, know that it attained fame after what is called a Jeopardy. There's a competition in the United States It's called Jeopardy, where essentially it's like a question answer system, like we have an Indian equivalence like Count Banega Crorepati and stuff like that, where we have quizzes and with prizes, things like that. So IBM Watson, they came out. See, even before this, along the Jeopardy, another landmark event which happened was that there was this. They had an artificial intelligence chess playing program, which actually defeated the then world champion Garry Kasparov many years back. Maybe many of you are either very young or probably not born, maybe just born. So that was another big event which happened. And Jeopardy was like more a difficult problem in the sense, see, chessboard is more like a structured kind. You have a board, you have positions, and you have all these strategies. The Jeopardy was very different in the sense it was like a question answer system. And topics range from anything, nature, technology, politics, the weather, geopolitical events, economics, finance, anything. So there was a bunch of topics, and essentially it was the championship was held by some very I would say experts. They were the repeat champions of that program. And in this particular event, the IBM put forward the Jeopardy artificial intelligence offering against the champions. And the great news was that I don't recall the exact date, but this program defeated the then world champion of Jeopardy. So just imagine, it's like a general quiz, general in the sense, most general. The topics are free in any possible topic. It could be medicine, it could be geopolitics, history, geography, politics, finance, economics, anything. And the event was such that there were questions being asked in different topics, different subjects, and the human or in this case the artificial intelligence system is supposed to respond back. And of course, the questions are not like binary. It is like, it could be sometimes may not be the exact answer, but the closest answer. So you have an equivalent right now in Tata Crucible for the, those of you who are in the engineering colleges, there's this Tata Crucible competition has been going on. Okay, so anyway, so this particular thing, in this particular case, the important thing was this, what had previously been thought impossible, a system defeated a trained and experienced human beings, a world champion to boot. It defeated them in this competition and won. And then the world took notice. And then I also talked to you about the chess, where it defeated the IBM, I think it was called Deep Blue system, defeated Garry Kasparov. More recently, the Google system's DeepMind, it defeated, I believe it's a Korean game. It's some kind of a board game with a lot of strategy and stuff. And many experts had kind of thought that it was impossible for a system, an artificial intelligence system or a machine or a program to defeat a human being. In this particular, the Google DeepMind, DeepMind incidentally was an acquisition Google made some time back. And this system defeated the reigning, I think, a Korean champion. And that, again, the world took notice. So these are some of the developments. I just wanted to set the context. So before I lose track, I'll just show I've given the word to Shrikala Madam, I'll show the slides. So let me just share that first. I'll finish that and then I'll start with my topic in full. So as I think both of my predecessors have said, we have we have this program, the Department of CS at a glance. So let me just show you this. The important thing here is that we have the World University Rankings and the Asian University Rankings here, number 1. And the important thing in India is the NIRF, very prestigious, I would say acknowledgement that we are number 4, the best university in India. It's very, very prestigious, where we have, and then World University Rankings, number 1 private university in India. So you can see the pedigree, right? As both of my predecessors were talking about, the pedigree is very important. Like since I've come from university, I know that because when I go for a job, I used to, now I'm pretty much advanced in that. When I used to go for a job, they first take a look at your background, right? Your academics and your industry background. And when they see my academics is from IISc Bangalore, Indian Institute of Science of Bangalore, they sit back and take notice. And the companies I work for, that also plays an important role. So, that's something you need to keep note of. So here is an excellent opportunity. And I think Shrikala Madam has also talked to you about. There are these different programs which computer science Amrita campus offers. and some of you are interested, want to get further details, we'd be most happy to send you the information of the different programs. So I just, without further ado, let me get to the topic.
Sir, you were asking for others, you were asking some question. Nobody would be able to participate because everybody's on mute.
Oh, yeah. I got it. Yeah, sure. That's understood. So what I'll do is, let me just, I also used to use Microsoft Teams and Google Meet. So I'm also, unfamiliar with the interface, Zoom interface. So I just wanted to get one control out of the way before I show it. I think it's not going away. Okay, anyway. So let me get to the slideshow. Okay, okay. So this is my, just a moment. Yeah, I think that's gone. So, okay, yeah, I think what all of you, the title of my present is slightly different from the title which Shikala madam had shown you. Why I put this was, so let me give you a brief about why I chose this topic. So I was told that there was going to be a group of people from, predominantly students, but also people who have actually completed the course, also who have actually set up some startup or industries, entrepreneurs, and possibly also some faculty members. So when I saw this heterogeneous kind of crowd, kind of people join this program, so I thought rather than getting to specifics, each of them may have their own specific requirement. So rather than making it very specific to each of the groups, I thought I'll make it a generic enough presentation so that it'll give sufficient interest to all of you. So the first part of my, and I got close to about 60 slides, so out of which about initial 20 slides is all about conceptual understanding about, I think Srikala talking about hot things called the, artificial intelligence, machine learning, data science. These are the buzzwords and absolutely hot areas for, which employers seek to recruit. There is a huge, I would say, set of openings for people who are familiar and have competence in the knowledge, the usage of tools, the workflows, and the different processes adopted with these different technologies. Those who know either all of it or aspects of it are in great demand in industry. I can tell you from experience, like IBM, HP, they are really looking out for good students and recruits who are competent in the different tools and technologies in the area. Okay. So, so as I said, I will be focusing on artificial intelligence, some kind of conceptual overview of that in the first, and also some practical aspects. And after that, I will take you on to the why all this start about, big data and the word big data analytics and all that. I will cover applications centered around that. Okay, so as I said, this is the broad organization of the presentation. So let me, without further ado, get into the next one. So here, first, I will start just to set the context. I'm showing you a study done by McKinsey Global Institute, and typically, where is the value creation happening from AI? Okay, AI is now, as you know, you open a business channel, ET Now or CNBC, or you pretty much open any business or other news channel. Use something or other about AI is always coming. You talk about Fortune magazine, Wall Street Journal, Economic Times. Any of these things. It has come to that level that AI is kind of disseminating. Like I've heard things about like Mahindra and Mahindra. They was talking about some kind of tractor, you employing AI technologies, smart tractor for, essentially cultivation, smart mechanisms of agriculture. You have agriculture, then you have, things like, we already know about, I think Srikala madam did talk to you about machines and industry 4.0, smart factories, etc. So the AI is going to go there. But if you see here in the study, still predominantly the coverage is still, but retail industry is going to be the early adopters of this. As you know, as an example, I will tell you, I'm sure all of you may have shopped in Amazon or Walmart, the online offerings. And one typical example I can tell you, an application of AI machine learning is the recommendation system. Like when you purchase something from Amazon, you'll see on the bottom, it'll say people who have purchased this have also purchased this. So that's an example, as some of you know, is an example of a recommendation, product recommendation. There's an engine running there, and it's able, and that's incidentally one of the things which has hugely contributed to success of Amazon and Walmart. The travel industry is another major adopter of AI, ML. Transport logistics. I have some example slides a little later on the presentation, which I will show. Then essentially things like high-tech healthcare system. Healthcare is also proving to be a major adopter, especially in the era of COVID, when you see a lot of data. Data collection is actually happening at a very wide scale. Some of you are aware of this, know that Johns Hopkins in the early days had come out with a dashboard, the COVID dashboard of the world. I hope some of you have seen it. It's a beautiful dashboard. And essentially it gives you a kind of almost like a map of the world with all the hotspots in the world in the different regions. And it actually has some drill downs where you can actually click on that and you can actually see the incidents, the trend lines, the daily, daily caseloads, and the trend lines, the fatalities, and all kinds of trend lines, and all this is available. That's a classic example where they've actually they're able to get data from different countries, different organizations, different hospitals. They're able to pull the data in and actually show you a beautiful dashboard. If you get a chance, if some of you have not seen it, you can actually take a look at the Johns Hopkins dashboard for COVID-19. Okay, and then many others: telecom, oil and gas, agriculture, etc. So let me, this is something which is more intuitive. Like people, when they talk about AI, they assume AI is making inroads into all aspects of life. Like the popular consumption is more like the, if you see the movie Terminator, right? You have, the AI programs which are taking control of the world, and, they're waging a war against the humans and so on and so forth. Now I'm currently seeing a movie called Oblivion, which is, I think, slightly old movie, which again is talking about, battle between the world and the other forces in the, universe. And they talk about a lot of technology and they are being at war. But this is actually more hype than actual reality. So people generally talk about two broad streams under AI. Even if you call it artificial intelligence, there are two, you can actually partition that into two different aspects. One is called artificial narrow intelligence, ANI for short, which is what most people are exposed to. The other aspect is called AGI, artificial general intelligence. So let me first focus on the ANI part. This is what we see, like that we are all exposed to smart speaker, so like your Google, Alexa, the Alexa, Apple Siri, and all these things, right? Nest, and that's one thing. Self-driving cars. You've heard about the Google self-driving car project. Then I believe Apple is getting into that kind of thing. Then obviously web search is more like a vanilla application. Web search has been where most of the internet giants have earned their bread, so to speak. Google and Amazon and Yahoo and stuff. No, Google and Yahoo and some others. And farming and factories are some more recent kind of things. As I said, smart factories, smart farming, precision farming. Precision health is one more area which is gaining a lot of traction. So now when we talk, the most of the growth or development of AI has been in this ANI basket. So even though we say that the whole field as a whole is evolving, if you see the bulk of the developments and growth and breakthroughs are happening in the ANI basket. AGI is still, there are a lot of open areas of research, where you're basically trying to mimic the human capabilities, intuition, things like intuition, how people think, logical thinking, how intuition strikes, how do you actually are able to gain intuition from a body of knowledge. All these things, the essential, we don't really think about it, how we perceive things, how we perceive, understand, comprehend, act, decide. These are intuitive. Humans don't even give a thought to it, but if you were to try to replicate this in a machine, it's a huge problem. It's very, very, very challenging. There are lots of PhDs and postdoc workers at universities doing a lot of work, seminal work, but we're still a long way off. Landmark breakthroughs are still few and far between. So if you see now, the bulk of the progress or the things which are happening is the ANI basket. Next, we'll just kind of step into some of you may know it, but I thought I should, since we have a diverse audience here, I would just like, and what is AI? We have, let me just set things in context. We have this whole body of knowledge called AI, artificial intelligence, and within which one of the most important tools or subsets of AI is called machine learning. Okay, so let me just show you some of the examples here. This this looks like some kind of a diagram, which gives you on the horizontal axis, it gives you timelines, how the progress happening in the AI field, and what are the breakthroughs. So you have the outside oval you have is like the artificial intelligence, broad feeling, where you're talking of enabling machines to mimic human behavior. So that's a broad, I would say, the motherhood statement, what artificial intelligence is supposed to think about. And then within that, you have this slightly, a machine learning, a smaller oval within that, which basically talks about statistical and methods. Okay, there are methods, even non-statistical methods as well, but statistical methods is one of the most prevalent, statistical learning as we call it. That is essentially you want methods to learn without being explicitly programmed. That means as opposed to a conventional program, a monolithic program that you have, where you need to, all the human intelligence has to be transcribed into code, right? You want to do something. Let's assume you have an, you have a financial portal or an income tax filing or whatever. All the rules need to be embedded into logic, which is the human learning is embedded into human knowledge, is essentially quantified into transcribed in the code. So you need to explicitly embed the human knowledge into the program. Only then it can run. The program by itself can only do a set of things in a mechanical way, but a human knowledge has to be embedded explicitly, rules and all these things. Whereas here what we are talking about is, we are talking about whether without explicitly programming it, the machine can learn. So I told you about, let me give you a couple of factoids here. I talked to you about the Jeopardy and also the deep the deep what do you call, the computer chess program. So computer chess program, imagine all the rules you would have fed it, all the valid rules. And any piece you take, it has a set of valid rules, positions it can make. Let's say a horse or a rook, as we call it, or a knight or a pawn. They all have some very specific moves. They can only, within that restricted set of moves, only they can move. So those are the rules. Okay, how much they can step, how many positions they can jump or move. What are the valid rules? All this is set. Okay, but beyond that, when you're playing a physical opponent, right, you need to improvise on the fly. On the fly, you have to improvise. You're playing a board game. The opponent, let's say Gary Kasparov, puts a move, a checkmate, for instance. So how does the computer program? That is where you need to have all this kind of rules, and explicit rules is one thing, but what is the process by which the computer is actually able to decipher, understand, comprehend the move your opponent has made, understand the context of the in the board, and whether it's a threat or a normal move, it has to strategize, and it has to make a counter move. Like game theory, we talk about game theory, right? In computer science, and mathematics, we talk about game theory. You have opposition opponents. I make a move, you respond, and then I need to judge for myself your response. I have to make a suitable move. So it's always a question of trying to find the best alternative, using all the tactics and my human experience, and trying to come out with a counter move. Like typical example in the business field is competition, right? When you have in a particular high competition industry, the company is always strategizing. They make a marketing and they put out some products or a particular strategy for marketing. So the competition, what it needs to do to counter that, otherwise they get probably out of business or they get their sales go down. So they have to counter. They have to come out, like telecom industry is one very, like the Geo has come in, and then they have put out a lot of strategies, cost-based and product-based, and Airtel, Bharti, and Vodafone are scrambling to, respond to keep their market share. So that's what I'm saying. So essentially, machine learning, when I'm saying that, these systems need to be intelligent, have so-called intelligence. They are able to learn. They're able to judge the context, come out of the counter strategy, make the moves. If it's a robotics, let's say path planning program, it's supposed to avoid obstacles. You give it a start point, the target, it needs to figure out. And you give it the map, digital, probably a model of the map you have. It is supposed to navigate the obstacles, come to that point. So there you'll see that it needs to autonomously. You just give it the capabilities in terms of cameras, stereo, the vision, the sensors, the locomotive capabilities, etc. But after that, you start it. Then it's all on the own. It knows the map. It has to figure out. And probably there's a dynamic. Let's assume it's a game, a 3D game, for instance. Just imagine the obstacles are coming at you dynamically. This guy, this robot, or whatever it is, has to figure out where the projectile or the opponent is coming forward. You need to probably eliminate an opponent, the positions are changing dynamically. You need to figure out, you need to use your vision, your AI, your position based, and figure out an alternative. Okay, so I give you a flavor of that. And then now coming back to my slide here, machine learning is probably one of the most important subsets of this. And within that, the last few years, the great traction, what you've got is called deep learning. I'll actually describe it a little more detail, but this is the broad set. There are bodies of knowledge outside this as well. Outside of machine learning, you have things like supervised learning, unsupervised learning. You have reinforcement learning, then graph theoretic. You have different algorithms. They don't strictly come under machine learning. They're slightly outside, but they all fall under artificial intelligence. Then you have this broad statement called a data science. Data science doesn't. There are different conflicting views on it, but data science does not fully fall under. It cuts across some of these areas, but also there are elements outside, which I will describe in a future future slide. So let me now, without further ado, come to this. This is a nice slide. I got it. I got this from the one of the portals here, and this summarizes. When you have, as I said, within AI, you have this thing called the machine learning, which is probably the most popular tool or method used within AI. And within machine learning itself, there are two broad. There are many as well, but these are the two most widely used. So unsupervised learning, supervised learning. And supervised learning, basically, unsupervised learning is where you don't have, you have to, the system or program has to figure out, only the data is given to it. It has to find out, basically gain insights and knowledge based on just the data. Supervised learning, you have input and output data, sample, what is called training data is given to you. I'll give you many examples as we go along. So broadly, you have unsupervised learning, supervised learning, and unsupervised learning. An example of this is clustering, what I will talk about later on. And supervised learning, broad, two of the most popular techniques are what is called classification, regression. Regression for what is called real valued. If you want to compute, let's say, the stock price or maybe amount of units sold by a company, you want to essentially, you have a ML program which will predict what are going to be sales in units of a particular product. I will use regression. If I want to, let's say, use classification, which is for discrete value output, typically, let's assume I want to know, an example would be weather. Typically, you see in weather channels, is it going to rain today? Is it going to be a sunny day today? Or is it going to be a windy day today? That's an example of a classification. You are basically, you have a discrete value data, categorical data kind of thing, and then you want to make a prediction based on that. Another example is a machine, like does somebody have COVID or not? So this is like a binary decision, right? You either have it or you don't have it. It's not like a what do you call it, a numerical prediction, but it's like you're predicting either a person has COVID, is infected with COVID or not COVID. That's also an example of a classification, a prediction. So let me first start with the unsupervised learning. As many of you already know it, but I'll just give it for the benefit of all of you. So essentially, you have a data set, and you don't have any what is called training examples or labels. And essentially, the system, the algorithm has to figure out patterns from the data itself. So here, if you see a very intuitive way, you see if you look at let's say distance measure, you can see that there are three groups here, right? Intuitively, a human just looking at it can figure out. You can have, and here on the right side, you say three different colors. So these three groups on the left side, left graph can be clustered. This could be one approach. There could be other approaches as well. But one approach is you have something called a decision boundary, and you can separate the deep blue one here. The right side is what you have is a light blue. The bottom is more like a golden or brown. You have three groups here. So you have inferred using the clustering algorithms. You have arrived at clusters and able to cluster the initial set of data, which is just given to you. You're able to cluster and find patterns in the data. So this is called a unsupervised learning technique. You're just the body of knowledge or the algorithm, which actually just given the data finds out patterns in it. Supervised learning, as I already told you, is it's a fairly straightforward definition that you're given the data and you're given what is called a training data. I'll give you a classic example which will illustrate this further. So if you have the data for the output and you use supervised learning, so typical example, there are people who told me that one of the popular applications is like you have share price, right? Everybody's trying to make money in the stock market. Now let me give an example. Infosys, right? Infosys has declared its results, and this results are very good. Incidentally, in COVID times, all the IT companies are doing very well. Now, suppose I have many insights into the industry. I know how the IT industry is working. all that. I can use my subject knowledge expert in that. I can always also use, let's say, stock price ticker information, like the National Stock Exchange, Bombay Stock Exchange, etc. They publish, if you see any of the business channels like CNBC, ET Now, Bloomberg, etc. They have tickers of the share price almost on a real-time basis, maybe 5-minute intervals or whatever. They keep showing you near real-time the way the share price are moving. So let's assume that you're let's say you're done a startup company and you want to, like, one of the classic examples is the broking company called the Zerodha. If you've heard about it, it was a fairly recently started. Maybe I'm not sure it's more than 5 or 10 years old. It is the #1 discount brokerage in India. It has gone ahead of all the other big time players. Of course, they are discount brokerage, but they also have a lot of facilities, which is very easy to use. And there are a group of people who are passionate about this. They started up a company called Zerodha, and they have, I believe, the largest number of customers in India for discount brokerages. You can do share trading, you can do ETFs, different I believe different types of securities. You have demat facilities, you have securities, and you can do trading, all kinds of things you can do. So now just imagine, let's assume you have started a company, and in the financial services space, especially securities trading. A good utility to have is if you want people to join your trading application, want people to subscribe to your trading, then what you would like to give them is a tool which will enable them to evaluate different securities, give them all the past data, the prospects for the future, and last but not the least, a new investor would like to know what are the prospects for the security. So if you have some kind of algorithms which can actually, based on all this data, the share price data, time series data, geopolitical news, economic news, management news, the industry news, all this, if you are able to distill all this together and help the investor to make an informed choice of the security, whether purchase, buy, sell, hold, prospects, compare between securities, etc. It'll be a great thing to have. So you can actually come out with and obviously AI would be a very, very important enabler of this, because AI is able to take inputs from different analyst estimates, company information, news coverage, social media inputs, time series data of the share prices, geopolitical events, news, take all of this together and able to munch this into a intelligence which can help the investor to make an informed choice about to purchase the security. So this is where the power of AI comes in. There are many platforms, like I'll give an example in the US, a very good platform which has actually become what is called a unicorn, $1 billion startup is something called a Robinhood. It's been there for a few years now. I think started by a set of Stanford students in their early days. And now they are, of course, very rich people. They've started this unicorns. It's called Robinhood platform. Okay, I gave an example of Zerodha from India. The example from the US is this Robinhood. Get a chance, you can look into it. Very interesting site. And it uses a lot of AI, and aside from transactional data processing and all that, it uses. Okay, so this is brought about supervised learning. So essentially what you're saying is, I give it training data, I give it samples, which helps the system to learn. And then once it learns, and once it's trained and learned, I have a model, I can actually do it for predictions. I'll give you concrete examples as I go along. So here is some intuition. Supervised learning, essentially, it is simple. It is most simple. It's actually, you can say, given a set of input, it actually can map it to an output. Okay, given a set of input, which is I call A, I can actually compute an output, which is called B. So let me give you an example, which will probably help you to understand. Some classic examples here is like most of you have used Microsoft's Outlook Mail and Google Mail and stuff. So there, one of the important features required is called spam filtering, right? So spam, there's the age of fake data and spamsters and etc., phishing and stuff. So you need to have a capability. How do you distinguish between a real mail, a good authentic mail, and a spam mail? Okay, so here is an example, like spam filtering. That is, you can actually, if you can have some kind of a program embedded in your email system, which is learns from your patterns, your usage of the email system, and is able to figure out what is a genuine email, what is a spam mail. So that's one application. Audio, this is a classic example. A very more older example is audio to text transcripts, right? So essentially you have typically if you, let's say an example is like you have this medical transcribing industry, right? You have essentially a doctor's diagnosis is recorded on a audio, and then you need to have a lot of regulatory requirements for the medical industry in terms of diagnosis, in terms of drugs prescribed, tests prescribed, so there's this transcription, and records need to be maintained in the as per regulation, health regulations. So you cannot just write. Every person cannot just go and listen to doctor's words and physically write. It's next to impossible. There's a huge number of content, and it's almost, that's where speech recognition comes in. So automated audio to text transcription. So there's a huge body of knowledge behind that, speech processing. And so if we get time, we'll cover a bit of that. So another thing is like automatic translation. Now, if you've seen the internet, right? If you go to let's say a Chinese site or something, it'll give you an option. They want to translate. So if I do that, it's actually physically doing a translation from English, let's say an English text to Chinese text, or Devanagari or Hindi. You have these capabilities available. This again is an AI program which does this. There's a lot of knowledge behind that. Those of you interested can look into this aspect. Another classic example of commercially, one of the classic examples which is uses ad platforms. And you want to do, web analytics. Web analytics is a very, very hot topic in business schools and technology engineering colleges. Like, and a lot of requirements for jobs here. People who know, marketing analytics and all these things, web analytics, they can, look forward to good opportunities in the industry. So essentially what it does is you have these ad platforms. So you have these companies, then there's this ad platform, then there's end users, right? So how do you find out? You don't want to just show any ad to any user. That's a very unintelligent, dumb way of showing ads to users, right? People are talking about intelligent, targeted ads. So essentially, is there a way that I can figure out the user based on user profiles or user web habits? What is the information on the web surfing habits? Can I figure out what are the user's preferences in terms of areas? In terms of do they like entertainment movies? What are they likely to shop? What are their surfing behaviors? What are the things that interest them? Those kind of things is valuable information. If you're able to figure out that, then you can actually show ads which are actually closest within quotes, which are aligned to these interests or are as per the profile of the user. You can show them targeted ad instead of showing in a very dumb way. Show them any and which ad which comes about. The click-through, what is called a click-through rates, becomes much more important. The payment for these ad agencies come up because one of the metrics we track is called click-through. And finally, obviously, the end result, the consummation of all this is when an actual purchase of a product or service happens. So click-through is a very important metric used. So that is where this particular utility, as I call it, AI utility, can play a great role. Can I intelligently, using the user's past history, web surfing history and demographics, and maybe pull data from social media and other sites, am I able to target ads at that user, maybe past purchases? Okay, I'm able to target ads at that user where the probability of that user clicking, getting interested in clicking is higher than if I were to show in a dumb, just throw an ad at him. So that's a very lucrative and one of the most, and from a commercial purpose, one of the most important applications of AI in the real world. Another application, yet another, as you go down the list, is you have this driverless, self-driving, what is called self-driving cars. And people are saying that, have been talking for some time that, the world is actually rapidly moving to an era where you don't need a driver. There'll be all kinds of capability, sensors and cameras and geolocation information, cameras and audios and distance sensors. All kinds of sensors are available now. You can actually incorporate all this, and you can have a system which will. The holy grail of this is that you can have intelligent cars which can figure out, can mimic human beings, their skills. You put them on a highway, albeit with some constraints, and they're able to figure out, like a human being does, how it navigates a highway. I'm told that in the autobahns in Germany and some of the highways, they're already testing it. That one of the reasons why India, it's a little difficult is because our highways tend to be a little more chaotic, like lane discipline and all that is a little difficult to implement. But some of the advanced countries like Europe and US, there's a lot of more lane discipline and all this. So then it becomes more easy for a machine learning system to operate in such conditions.
Then another example, which is again, I've seen when I was IBM, there was people are talking about the visual inspection. Like typically when you are, let's say you have a manufacturing concern, manufacturing some discrete products. An example would be, let's say you're manufacturing some kind of valves or some mechanical component. Okay, so one of the things that you want, one of the important performance metrics you use when you want to look at the manufacturing efficiency is what is called the yield. That means of the inputs you give from the inputs you give, in terms of raw materials or whatever it is, and then it takes it through many set of processes, and finally what you get is a finished product or a product which is part of a bigger assembly. So how do I know that the product which I'm getting out of this, what I give as an input and coming out is actually is good, or which satisfies the requirements? Now, one option is obviously do 100% sampling. You have a human being sitting there examining each of this for maybe appearance, mechanical qualities and stuff, and then passing it on. But that is, as we all know, is humongous and very difficult to implement in practice. So what people in the technology industry are looking at is, can I intelligently use, there are a lot of advances in image technologies, cameras, and a lot of very, very advanced image processing algorithms, computer vision, video analytics. Excuse me. So can I use some of these capabilities to do automated inspection? So let's assume that this product which is coming off the assembly line. So I have let's say camera station where this, all these parts are coming and getting dumped. So I can maybe with some spacing or whatever. Otherwise, if all of them clubbed, you obviously cannot do it. So let's assume there is some spacing. So similar to social distancing, let's assume there is a spacing for the parts. Can I use maybe a real-time camera feed of that, or a video feed, and then in sufficiently short time, can I certify that the product is at least appearance-wise or from the image? Can I say that it is free of a defect? Like typically, if there is no defect, zero, it either has a defect or no defect. Okay, I'm not taking the case of partial. We just talk about binary. That is, either it's normal, either it's proper, or it's a defect. And then if I have the capability to do that in real time, near real time, then I can actually physically, I can segregate the products which come out, all the so-called deformed or malfunctioning or damaged. I can actually put them in a different bin. Only the products which pass the muster, I can put it in a different bin, and you can eliminate human, inspection there. So there's another, taking which is getting traction. And one more industry. Those of you in the electrical and utilities, who come from that background, see, you have these transmission distribution lines which are, span the countryside, right? So just imagine if you have a storm or a wind or something happens, a line breaks, right? Now, recently there was an example, I think Maharashtra somewhere. There was one of the major transmission lines. There was some problem, and there was a total blackout. Now imagine the scene where, if you were in the old scenario, is that you would need to physically isolate the fault. Of course, electrical engineering have ways of isolating, faults by sending signals and stuff. But that again is not 100% foolproof, and you cannot maybe not precisely identify where it is. And you have to send out field teams to go out, examine. And just imagine, these are towers, probably maybe 100 feet, especially interstate, transmission lines. These are at a very great heights. So imagine you need to send people out. You need to figure out with all kinds of cranes and equipments, go out there, identify where the problem is, repair it, all these things. Okay, so here now people are talking about interestingly using drones capabilities. I can use, and I can embed high power cameras and intelligent algorithms into that, which will probably just go along, scan these what I call is these infrastructure assets, like let's say, for instance, transmission distribution cabling or transmission towers. I can do a sweep through that. And I can essentially physically, if I see that there is a wear and tear or some lightning strike or some damage happening, I can quickly figure out, before the actual physical line gets snapped, I can take corrective measures. So this is a classic example where I can, do before the actual physical event happens, I can take proactive actions and ensure that the service levels are at high levels and customer satisfaction is not compromised. Next slide. So here is a very simple, intuitive explanation. I told you, this is a classic example in the load. Now, incidentally, just give you an example. There was, if some of you may have attended, there's a very nice Stanford University machine learning course offered by Professor Andrew Nick. This, I think, initially came out in the year, I think 2012 or so in Coursera. I had actually taken that course. Get a chance to do it. It's a beautiful course. It talks about examples called, one of the examples given is called house price prediction. Okay. So I told you about, recount, I told you about machine learning. So at its most simplest level, it is like A to B mapping, A to B. Given a set of input, find a set of output, right? That is what. So, and here, as what did I say about supervised learning? I give you training example, sample example. So let's assume I have a table like this, okay? Past data. So let's assume it's square feet. I have these 6 pieces of data here, samples. So let's assume that a 523 square feet house with 1 bedroom is sold. Let's assume it is sold for a price of $1,000, and so on and so forth. 6 pieces of data given. Okay. So here, if I were to transcribe it, or rather related to the what I said about supervised learning, A is the 2 columns. Here in data, the parlance, there is something called, people call it attributes, some people call it features, etc. So you have these attributes, features, some people call it independent variables, and the attribute or dependent variable, which is B, or the output variable, is here in this case is price. So essentially, picture in your mind, you're doing an A to B mapping. So I have to come out of the system, which actually, given this training data, it learns from it. And so that is the learning part. Learning, I have to build something called a model. The important is that given a new data, okay, let's assume I have a size of the house, a new data, right? Somebody wants to look at whether I have a 1,500 square feet house with 2 bedrooms. What could be the price of that house? It's a new data. It's not there in this data set. The system should have the capability, after having learned this data, having built a model, can I actually use the system to predict for a 5,500 square feet with 2 bedrooms, what is the likely price? So that's an example of a house price prediction utility, or a house price prediction problem. So another example I can give you here is, again, supervised learning, A to B mapping, input to output. When you say A, look at input, B is output. This is one of the early folklores of, I believe in Google, they had a system which is like recognize the image of a cat. Okay, so given a myriad number of images, can I recognize a cat from other images? An example here I will give you is just an aside here is from, you would have seen these CAPTCHAs, and especially in Google, you see, right, just to security address concerns. They have actually put out images and ask you to click on this. And if you make a correct matches, they permit you to go inside. So this like the CAPTCHAs and all this real-time challenges they give you. This can possibly be using a utility like this. Let's assume given some image, can you recognize what the image is? So in this particular case, I'm talking about cat. So the first image is a cat, a label. The second is a bicycle, obviously not a cat. Third is a cat, a different cat. Fourth is a car, not a cat. So if I have, let's say, 10,000, 100,000 images of this, I can actually feed it to a system which can learn. It can have sufficient data set to learn what is a cat or not a cat, and with a sufficient level of accuracy. You can have to have these machine learning systems. People look at a good system will have in the 90s, advanced 90s. The more the performance, the better. If you have accuracy of 99% or more, the better. Especially if you're using, there are some banks and some other utilities, some other business, functions, security functions. What they are saying that they're using face recognition. Face recognition for, for security purpose. Let's assume you have employee ingress into a factory. Correct? Let's say you want to use a face recognition system. So just imagine the price you pay for bad misclassification is quite high. You can't let in some a thief or an outsider intruder to get into your factory premises. So imagine the impact of a non-misclassification could be pretty bad. So you need to have very high accuracy systems. 99.9, people talk about 99 point, etc. But of course, it's not as easy as it said. A lot of work is required. I will later on talk about a bit about neural networks. Neural networks, incidentally, is one kind of a system which has a high degree of, it's achieved high performance in the case of image recognition. So now let me just talk to you another practical aspect of it, right? If you're, let's say, starting an AI company, one of the important things is data. Okay, how do I get data? Let's say you want to start a company. I talked to you about securities trading company. Now, let's say you want to do for a better example, let's say recognize a cat or recognizing, let's say, a bird or a flower, for instance. You want to set up a system which can actually, and you want to, set up a utility where maybe for a paid service you want to give people to identify. See, one of the things I do is, let me give you an example, is Google, there's something called image search, right? Many of you may have used it. So let's say I kind of like these castles and old buildings. Okay, so sometimes in the internet when I'm browsing, I see some very quaint castles. One of the castles I've heard about is in Germany. It's called Neuschwanstein Castle. I hope my pronunciation is correct. Beautiful castle it is. So let's assume I see the picture. I don't know what it is. Okay, and some of the aficionados or passionate people who are passionate about castles want to know which castle it is, where it is. So Google offers a thing that you can actually take a snip of that castle, which you see somewhere, either as a thumbnail somewhere or in some web page or somewhere, or in some PowerPoint, somewhere you've seen the thing, which gives you only the image, but it does not give you the description or the metadata of about the castle. You can physically actually drop it into Google Images. Google Images comes out with suggestions. It can find the nearest match. Okay, it's not okay. The algorithms kept on improving. It is now much better. For some static objects and some objects like buildings and with regular structures, it's achieved a pretty good degree of performance. But if you look at humans and especially humans, either the quality of the image is not good, or in different orientations, not standard orientations, different colors, different textures, different backgrounds, system finds it a challenge. What is the image? So typically when you say you have object of interest, in this case is just a cat. You're not interested in the background. The background may be some texture. You want to figure out only the cat. You don't want to look at the texture and do matching. So the systems, as you see, have to have the intelligence to focus on the area of interest, the object of interest or entity of interest, and try to do the prediction only on that and not on other extraneous matters like lighting, texture, what else, whatever other things. Okay, so that can. So let me give you one more example. In IBM, when I was there, one of the projects we took up was, there's this large conglomerate called Lotte, correct? So Lotte is a supermarket, high-end supermarket chain. And so they're into different products, textiles and fashion items and grocery items and confectionaries and what have you. So one of the projects, we had this Watson team, and we were actually consulting with them for essentially, what they wanted was something called a shopping advisor, correct? Shopping, what is a shopping advisor, you may say? Don't people know what to shop? No, it's not like that. So essentially, some of the capabilities they wanted was, and obviously they wanted to do a web app, okay? An app which would run on the web. Aside from giving some vanilla, basic inputs like directions to the store and where the store is and what items are there in the store, what floors, that is very basic data. The citizens, or rather the customers, wanted to ask some questions like, let's say I've seen my friend wearing this costume, maybe some beautiful coat, or maybe some hat or a bag. Can I, give you a picture of that image, and can you tell me, A, do you have that item or something close to that? Which brand it is, where it is located, is it in stock, stuff like that. Just imagine. If you've heard what I'm saying, there's a beautiful example, very complex as well. The user in the shopping assistant is asking for whether, can I just drop in an image and can you tell me which is a product from which brand, and obviously they will specify the size, the color they would specify. Can you give me a match in which store, where it's available, direction to the store, price for that. So this was one of the projects we were working on, very complex project in a Korean operations. Lotte is a very huge, one of the largest, I think, retail chains in Korea. Now we have the big ones in India as well. Now, other than Amazon, Walmart, you have a geo retailers coming up. Tata's are coming in a big way. So all this will, at some point in time, come here as well. These requirements like this. So yeah, now I talked about manual laboring. I'm talking about some of the business, requirements coming in. Now, okay. Now the question is, where do you get the data? That's a $64,000 question. Data is probably the most precious commodity here. Okay. So data, in the case of, let's say you have an e-commerce site where you are actually, users are actually logging into it and doing purchases. it's something your weblogs or others will actually capture this detail. Maybe a user ID, timestamp, maybe the price at what they purchased, what is the price of the product they were surfing, what is whether they purchased, not purchased, whether they're just browsing, they just visited, did some window shopping as they call it, or just pushed away. And then you can do actually what do you call it? You can do forensic, not forensics, not the word. You can do a what is the word to use? You can do some post-facto analysis. If you say a customer has come up to a stage of a cart, add a cart, and did not purchase. Now, one of the customers they want to do is a company, or rather a vendor or a retailer's main target is to make sure that the customer gets inside, has a sticky website where they spend a lot of time, and finally consummates a purchase. Not just a purchase. Ideally, they would want to what do you call upmarket, cross. They want to see customer may have come for something. They have to cross-selling. All this is part of the marketing folklore. Are you able to entice the customer to not only look at the product or offering they're looking at, also look at other things, using recommendations, using promotions, etc. Can I entice them to do purchases? And I should consummate the purchase. They should physically come and purchase the item. Only then I can say my end-to-end customer, I would say, engagement has worked in that particular transaction. So now coming back to the point, how do you collect the data? My weblogs, I can collect the data. It is there in the weblogs. I can get the data coming in. Let me talk about another example, another scenario on the right side of the table. I'm having, let's say, a factory or manufacturing. I gave you some examples some time back. I'm manufacturing discrete items, maybe a valve or some mechanical component or etc. And I want to, so essentially, machine data, correct? I may have a lathe running, I may have a boiler, I may have some other running, or a milling machine, spinning machine, etc., etc. I have different machines. All of these machines have the capability to, they have internal, they can generate data if you embed them with intelligence. The only problem which people have been facing, especially in Industry 4 context, when they're looking at making smart factories, are there enough standards? Are the data in a form that can be integrated? Are they in a proprietary format or in a standard-based format? Can I capture it? Can I actually upload, download, exchange data? All that thing. So maybe let's assume, give an example of a lathe. Let's assume the lathe is manufactured by XYZ. Maybe I don't know. Maybe earlier there was HMT here. In foreign countries, there may be different other companies. Okay, so let's assume it make it, and let's assume that they have some sensors embedded which can actually give you the tooltip speed, the temperature, if there are any vibrations, and maybe some other things. Okay, they can do the pressure applied, all that. Let's assume I can capture. So that could be, that's a little more, but here I'm just talking about machine ID. The machine, let's say lathe, can ID, the temperature, that could be pressure in PSI, pounds per square inch. Now here, the important use case here is that, especially in Industry 4 kind of scenario, preventative maintenance. That is, can I figure out machines, obviously moving parts, they can get damaged, right? They can get, they have downtimes. As those of you who are taking up manufacturing as a specialization, we know one of the things, performance metrics you want to do is make sure that the downtime is less. When a shop floor is running, you cannot afford downtime. Downtime is very costly because the jobs are scheduled, the machines are there, and each one has to play their part. Downtime is a strict no-no. If a downtime comes, there's a lot of money is lost, the job delays happen, and people get worked up. So if you have the capability that, let's say with all these IoT sensors, you have a lot of sensors available for different temperature sensor, pressure sensor, all kinds of things. You can have time sensors, gas sensors, pollution sensors, temperature sensors, weather sensors, moisture, humidity sensors. You can actually instrument this machines with these sensors. I can physically capture it into some kind of IoT platform or gateway, and I can get the data here. And then I can use that data to actually build what I call it a preventative maintenance system. That is, using this data, maybe on time series data, maybe near real time, 1 minute, 5 minute intervals, or 1 hour data. I can actually build a system using this intelligence, and I can also capture other things. If I notice vibrations coming in, then maybe that's an indication that maybe the system needs a servicing, or or maybe its lubrication is actually not up to the mark, or maybe some parts are getting worn out, or the life cycle, maybe some parts are near fatigue, they may get damaged. I can infer all this from this, and I can build a preventative maintenance. That is, you must have heard about terms like just-in-time, Kanban, and agile systems in manufacturing. So essentially, there are, prior to this, all these intelligent ways of working, you had time bound, it is called, on a calendar, you say every 6 months I'll come and do a servicing. Or I can do the worst cases, once the system breakdown comes, I can come and do a repair, which is probably the worst thing to do. The other thing is also not very efficient. I have a calendar base. I get into an AMC kind of thing, annual maintenance contract, and every 1st January, somebody comes in, he comes to your shop floor, he checks your machine, maybe oil and coolants and this and repairs, cleaning and all these things, examines it, does a servicing, goes away, takes a report, goes away. But if you notice, that's not a very efficient way of doing. Also, then sometimes they may say replace the part. Now, replacing is also not those of you get into, if you become entrepreneurs, you become startups, etc. These are all very expensive equipment. You want to have maximum life cycle. You don't want to beforehand. Let's say the life cycle of let me give an example. I have a car, right? A Hyundai Santro car, right? So what happens is that typically now, obviously after a certain number of years, you need to get in for servicing. Some parts start, alignment goes away. Some gear, clutch, brake system, things start wearing out. So ideally, there are multiple ways you can look at. Now, some people take a thing, they sell off the car, but that may not be very okay. Yes, you have to sell it out, but is there an intelligent way of selling it? Like I can extract the maximum useful life of the car, and then purchase a new car. So what will help me? That analysis like this, what I said, if I can get the state of the machinery or the equipment, and if there is some intelligent system which can tell me, is the health good, or is it getting into a zone where it is likely to fail, or it is critical case, it'll help me to make a decision. Correct? I'll give you a simple example. All of you probably have laptops or desktops. If you go there, all these vendors, system vendors, they give you utilities where you can actually check the health of the battery. If the battery is in good condition, is it charging? See, batteries are actually, they have multiple different metrics by which you can get the health of the battery. The charging time, the number of cycles it goes through, the heat generated, its charge retention capacity. So typically what you expect is when a battery charges, you expected that when it's fully charged, it'll last you for maybe 3-4 hours, and then you need to recharge. Now, I had an earlier laptop where for some reason the battery got compromised, and I charge it. Within 20 minutes, it says recharge again. So the battery's capacity to retain charge is compromised. So that all comes under the body of what I call the health of the battery, health of the system. So if I have a system which can actually, having a lot of knowledge, obviously it has to have a lot of knowledge to come to the conclusion. Let's say experts who are, maybe it's a lithium-ion battery, or it may be some other gallium arsenide or something else. They actually feed their domain knowledge into a system where you can actually, maybe rules-based, it can be a rules-based thing saying that if the temperature is so and so, or if the charging takes so much time of charging, or if the number of recharge life cycles has exceeded, let's assume 10,000, then maybe replace something like that. Let's say if you can encompass these knowledge into rules, then I can actually build the equivalent of an expert system where I can actually put it inside. I can look at the state of my battery, how many times I've charged, recharged, look at the profile of the battery, collect the data, use these rules, and I can actually come out with a prediction whether the battery isn't healthy or not healthy. And last but not least, I think I've diverged a bit. Got diverted a bit. The third option of collecting data, as I said now, is you can actually collect a lot of websites like Kaggle, government websites, etc., which share a lot of data, health data, planning data, financial data, demographic data, geographical data, etc. So this is all some of the mechanisms you can actually collect data. And if you cannot get all this, you can get data for purchase. You can actually purchase. There are vendors who actually curate the data and give it for a price. Now let me give you another practical. How much have we? We have, I think, gone through about half an hour, right? Half an hour. No, okay, I'll speed up a bit. Okay, so another one of the practical considerations we have to look about when you actually start a system is that data is, some people assume, okay, I get the data, I input the data, and that's it. I'm up and running. No, it's not so fast. So take the example of the right table, a small table I have, which incidentally it comes in the neat tables and columns kind of a structure, which is called in the AI or big data, this thing, it is called as structured data, because there is a clear structure. Fields, attributes have got a certain type. There are a fixed number of attributes. Only data conforming to this kind of schema, what I call a schema or type, can actually fit into the table. So it's called a structured data. So I have these things here. Look at the example, the table here. I have in the bedrooms number of bedrooms column, I have 2 entries which is called unknown. That means I don't have the data. Data is not there. Okay, so that's one example, practical example where missing data is there. Look at the column of price. I have the second row. I have a price of a house, which should be what? The others are all in some hundreds of thousands. This gives it as 0.001, which is obviously absurd data, right? Some people call it outliers, some call it absurd, not valid data. So you have to actually look into all these aspects before you can even start running your machine learning algorithms. You have to do all these, pre-processing activities, data validation, data cleaning activities. You have to do all this. You have to correct the data. Of course, there are a lot of techniques. I will not get into that in this webinar. We can, if time permits, we can meet again later on. There's a whole body of knowledge for that. We can discuss that later on. So as I said, there are incorrect labels, missing values. And then there is yet another type of data, broad classification, structured data, unstructured data. Typically images, all your social, in the social media, what you see is things like images, video sharing, image sharing. You can share clips, YouTube, you can video and audio clips can be shown. Text, typically emails, you have text. Emails also comes under, text data also comes into texture, because unstructured data, because they don't comply to what I call a structured schema as is shown in the right side. So let me give you another, some of the people have confusion. You hear terms like artificial intelligence, machine learning, data science, deep learning. What's all this? Are they the same, or are they synonymous? Are they different? Now here, let me give you an example here, okay? So let's assume you have a data of this type, home price. I give an example, a little more features. So let's assume you have, other than just the size of the square feet and number of bedrooms, I also have number of bathrooms. Is it a newly renovated house or it's a legacy house, old house? What is the price? Let's say I assume I have the data, okay? A machine learning system, as I said, is just an input. You're given an input, find out A to B mapping. So essentially, it is consummated as a software system, machine learning system, which is running on a mobile system or on a website or app. Feed the data in, it is able to come out of you feed the data, if the model is trained, and it can actually do predictions. Given a new set of data, a new data saying that 1,500 square feet, it has, let's say, 3 bedrooms and it has 1 bathroom. It is not newly renovated. It gives you an indicative price, predicted price. So that's a machine learning application. What is data science? Is the same? No. Data science is very different. Data science is saying that we have given the thing, you actually can analyze the data. You probably have some teams working on this. You can actually evaluate, look into the data, and you can actually come out with insights. So let's assume here one insight is, you can find out from the data that typically it looks like homes with 3 bedrooms are typically more expensive. Given the same square feet size, if a home has a 3 bedroom as opposed to 2 bedroom, it is likely to be more expensive than the same house with the same square feet than with a 2 bedroom house. That is one insight. Another insight could be, if you have which is obvious also, intuitive, a newly renovated house comes at a premium as opposed to an older house. So these are something which come out of from a data science project or a data science team. They do the kind of outcome coming out of a data science scheme is things of this kind. So typically, a machine learning system comes out with have a running program, which is probably 24/7. You can give it data, it comes out with a prediction. Data science, typically you put your team to it, maybe a marketing analytics team wants to look at what are the learnings from a market launch. I've launched a new product into the marketplace. What are my learnings? What can I do to improve? You give it a lot of data. They do of the purchases of the customers, their sentiment on the social media sites like Twitter and other comments about it, their purchases, purchased, no purchase history, weblog history, etc. And then you can analyze all this, and then you can come out with insights into methods for improving sales, improving customer satisfaction, etc. That is a data science project. So now, just an aside, it won't look good if I don't give a definition. So machine learning and data science definition, right? This is a classic definition given by a gentleman called Arthur Samuel, as early as 1959. He was incidentally the person who authored the checkers program, automated checkers program. It was like a game, a board game like we have chess. It used to be called checkers, right? So essentially, he was looking at methods to actually have a computer utility or program which can play the game against a human being. So that's an example of a machine learning program. As I said, data science is a different thing. You're saying you're the science of extracting knowledge and insights from data. That is a data science. So I talked to you so far about supervised learning, unsupervised learning. There's yet another technique. I'll just not stress much on it. This is called reinforcement learning. So whereby you are given two things, like you're given an environment, and you're given what is called an agent or an intelligent agent, and then essentially it's like a looping thing. You actually sense that the agent is actually able to sense the state of the environment, take some action. Obviously, there is a whole body of knowledge, what action to take, etc. Now, see, there is a beautiful book, if some of you are interested. There's a very voluminous book, by the way, Russell and Norvig, Artificial Intelligence, and they talk about all about intelligent agents. Typically, if you're talking a robot which is trying to navigate a cluttered space, it uses such kind of robot navigation, okay, or even in a board game like chess, you have the context, you have you want to take a move, right? So you have to have some ways of quantifying what is your current state, what is my position, what is the opposite position. And if it's a chess program, it will evaluate maybe tens of thousands or maybe millions. In the case of that Deep Blue against Garry Kasparov, evaluates alternatives, evaluates it against some kind of a score. What is the move I should take which gives you the maximum reward? See, please note it is a subtle point. Now, for every move you can get a score, which may be good. But I have to keep note of two things. One is my immediate move, which is my 1 or 2 moves, and one is the final outcome. I have to win the game. It is possible that my next move may give me a good reward, but it may not allow me to win. I may lose. So it should not only take note of the immediate move, it should keep in mind my final outcome, perceived desired outcome, which is winning the game. I have to beat the opponent. So look at the subtleties. So that is where the computing power and all this AI comes in here. So essentially, you're talking about take an action, you have to take a decision. Agent performs an action on the environment. So maybe if it is a robot, which is, let's say, manipulating robot, which is taking a piece of one, let's say, a block from here, putting in another block. So it's performing. Pick the block, put it there. So the state of the environment changed, right? Earlier, the block was sitting on the right side. Now, after the block is one block down, let's say like a Tower of Hanoi or whatever, on the right side, one block has actually got shifted from A to this side, left side. State of the environment change. So understand the new state and go through the loop. So this is what is called reinforcement learning. This is another fairly well researched and a lot of research going on in this area as well. And of course, there's a very intuitive explanation. All of you have heard about deep learning, correct? Deep learning is one of the hottest areas right now. And I will also show you a slide towards the end about an intuitive understanding of what is called deep learning performance. Okay, I'll come to that. So here, if I can transcribe the house price prediction problem into the the deep learning into the house price, how I solve the house price prediction. So from the left side, what I call input, I feed in the size, the data set. I'm basically feeding in the data set, number of bedrooms, number of bathrooms, whether it's newly renovated or not. Now here, the oval or the smooth oval, no, not oval, I mean the smooth rectangle in between, you have what is called nodes. You have hidden nodes, input nodes, hidden nodes, and what is called the output. The colored one on the right side is called the output node. So essentially what you're trying to do is you're mapping from A to B. A is all these attributes. I feed it to the neural network. Input nodes, it does it does something like a black box. It does something inside, comes out of the price on the outside. So why this is also synonymous, deep learning is also synonymous, used in the literature as what is called artificial neural networks. Now you might ask, why the word artificial? Yes, it is artificial because neural networks are modeled, or rather people have tried to model it on the human brain, where we have what is called neurons, natural neurons, biological neurons. So these are artificial. So there's called artificial neural networks with a lot of connections, synapses, connections between the nodes. And inside is a black box. How it does? There are a lot of algorithms. You have deep learning, algorithms, what is called backpropagation algorithm, then the equations which map onto the inputs to output. It's a huge body of knowledge. There's a method of solving for it, and there's a lot of computation involved. Okay, you can actually errors, you backpropagate, you tune it, and then you come out. And strangely, what happens is, you might ask, how does it? It finally solves the equation, converges the parameters and the weights get tuned, and finally you're able to solve it, and it's able to come out with a prediction. Okay, so that is deep learning intuition. There are a lot of research going on. In Canada, I think it was was it Concordia University or something? Jeff Hinton, one of the pioneers in this work. There are many others as well. Facebook, I think Yoshia Bengio, I think it is. Lakun, what's his name? I don't get the full name. There are a lot of pioneers who worked in this area, deep learning. It is the reason why deep learning is actually, the neural networks, and there used to be an earlier some algorithms called genetic algorithms earlier. It attracted interest and then went down. Then later on it kind of interest went down. The factors which actually contributed to renewed interest in deep learning is two things. One is much more powerful algorithms and discoveries have made. That's one thing. And there are proofs basically of convergence and so on. Mathematical proofs are there. That's one thing. The theory itself is much more robust, so to speak. And second is that a lot of computing, because these neural networks are very good, very efficient, but they also require a lot of computing. And especially people say that there is one, I would say, this thing saying that the more deep the neural network is, the more features it can make, the more accurate, the more performance it can achieve. As I said, I have an intuitive slide somewhere down the line. I'll show you that. So anyway, to cut a long story short, this is neural networks at a very intuitive level. What it does, it is also doing the same thing, mapping from A to B. Like I said, machine learning, give it the set of input features, attributes, map it, find the price. In the case of house price, this is the way it is done. And yeah, this is the slide I was talking about. So here, this is a very, very interesting slide. Okay. See what we call as, remember I gave you some examples of AI, traditional, what is called traditionally as speech processing, machine translation, and measuring the, prediction, the click-throughs, so given a customer and his profile, user profiles, web behavior, and what is the probability or possibility of a customer clicking an ad. So those are all, this has been there for some time. Okay, speech processing systems, image recognition. These are all traditional AI systems. Traditionally they have been implemented. Then, as I said about neural networks, I gave you an intuitive explanation in the last slide. So then you have, look at this graph. This is a very fascinating graph. This was actually articulated by no less a person like Professor Andrew Nigg himself. See, you look at the horizontal graph is about amount of data. Okay, and the vertical axis is about performance. Performance could be accuracy, efficiency, a number of correct classifications, accuracy, etc. Those are all measures of, and maybe also the time of execution. That could also be one. How good the learning efficiency, how good is the model? All those are indicators of performance. Okay, so if you see the graph, what is fascinating here is that in the case of traditional AI, if you see the bottommost curve, what you have is that it rises. Initially it rises and then it kind of flattens out. Okay, at a certain performance levels, giving it more data does not meaningfully improve its performance. It kind of saturates at that level, correct? And beyond a point, giving it new data does not really improve the performance. Now, as you look into the neural networks and deep learning, you see a very fascinating thing. You see that the blue one, the violet one, and the green one, you see that it kind of keeps increasing for longer and longer times as the number of data is given is more and more. So much so that when you lease a large neural network, a lot of nodes, a lot of hidden layers, a lot of joins, network, a lot of edges and connections, it for a much longer point of time, it keeps increasing as you give the data. As you said, now we are in the age of big data. As you go towards right, you're talking big data, large, from terabytes to petabytes to zettabytes to you name it. You're talking of the system keeps improving, the performance keeps improving, and the accuracy. That's a fascinating insight which comes about from the study of neural networks. So the modern day neural networks are able to improve their performance for much larger than the conventional AI systems. No doubt, as I said, the algorithms have improved. There are much more powerful algorithms there, and your powerful processing capabilities now. You know, you've heard about the famous Moore's law, right? Every year, I think it keeps doubling, year or year and a half, whatever, doubling. The cost keeps going down. We are all aware of the chips, the semiconductor chips, how capable they are getting along. More and more powerful chips, powerful processors, and then you have the specialized, things like GPUs, graphical processing units. Typically vendors like NVIDIA, etc. You have seen architectures coming out which are, have GPU-enabled processing, which are, basically performance optimized for machine learning and deep learning workloads. Even so much so that vendors like Intel and others have offerings in the deep learning. On the silicon, they're trying to embed some of these hardware acceleration capabilities right into silicon. So when you have all these capabilities built in, neural networks suddenly looks very attractive. You can actually keep learning, keep improving the performance for much larger than traditional AI systems. Okay, so see, I'll give you one example. I mean, it won't help. It'll help to give an example here. So all of you know there's the era of speech processing, right? You have, examples: Amazon, Alexa, a lot of adoption, even in India. Google Home, Apple Siri. Okay, these are things that typically retail customers they started actually making inroads into the home, as well as also other enterprise applications as well. So here, do these whatever insights or intuition I mentioned, do they apply for these a modern contemporary application like speech processing on these systems? Indeed. So let me give you a very, very intuitive explanation. Let's say I'm a company which is actually doing let's say I'm going to offer a service centered around Alexa. Okay, Alexa, I want to give it maybe a smart home. Okay, smart home. I want to set up a company which will actually help the customer to do a number of things. And at home, some tasks at home. I want to give an Alexa which is tuned. Okay, so what are the things I could do there? Okay, Alexa itself has certain base capabilities, but how do I physically deploy this? Okay, if I'm the vendor, I'll have to do these kind of things. So typically, here you're talking about understanding speech. Okay, so there could be words: Alex, hello, Alexa, how are you, Alexa, good morning, whatever. So many words you actually communicate with Alexa. So these, typically what you do is, in this case, the data is that thing. You physically clips. So I'm not talking of Alexa running. I'm talking about setting up Alexa, right? How do I tune it for the customer? So let's say there is an n number of words or something. I physically, maybe the vendor himself does it. So they'll find out what are the kind of what are the words that the customer is likely to use. Now, if it is an English-speaking word, it'll be English. If it is, let's say, Kerala, it will be Malayalam. It could be Kannada, or it could be Hindi, depending on the customer base. Okay, depending on the natural language which the customer uses, you need to have a corpus of these words. So let's stick for English for right. So I say, hello, Alexa. How are you, Alexa? What day is it today? So whatever. So like that, there are many words. What is today's day? What is the time? Okay. So I need to physically record this in clips. Remember, machine learning at a most basic level, it is A to B, mapping A to B, input to output. So what you're doing is, in this case, the input is a lot of audio clips of these words, like Alexa, hello, good morning, whatever. So you feed it. So that is the data that you input to Alexa. Okay, so you did the training on these words. And the blue ones I showed here is what you did the training in the lab or the company. You did the training. You deploy the model. It's a speech processing model. You deploy onto Alexa, and you deploy it into let's say the endpoint, that is, which is, let's say, customer site or customer site. So I give it as a green, in the sense that's a, now it could be either be in the same kind of thing, or it could be different. Now, let me give you a counter example. Okay, let's say I designed this, let's say in the Alexa is an American, like Amazon, correct? So let's assume it's done in Seattle, whereas the Amazon headquarters, just as an example. And let's assume the customer has bought it on the e-commerce site in Britain, Great GB, England. So I marked it as green. Why? What potential problem is that? Now, let's say the Alexa system is sold in Seattle or some part of US. There's no big deal, because all the keywords or the audio clips I've given will close match, because it's American speaking. I probably won't face much of an issue there. And if the training and the model is done well, good model is built with all the performance, satisfying the performance criteria, it is likely to work well. Now, you may have some accents which may give you problems. Okay, that's a separate thing. Now, let's say I've installed the Alexa system, the speaker system in the smart speaker system in England. Now, somebody talks in a Brit accent, right? Instead of saying Alexa, he talks in a slightly clipped word with a slightly different accent. Now, imagine what will happen, right? If I don't take care of it in my training, the system may find it difficult to understand, because your idiomatic usage of English, your accent may be different. So then what happens? So here is where it comes. The training and the model building is not a one-time effort. So that's what it is. Once you deploy a device or a solution into the marketplace, you collect, more data is getting generated. So you'll have to measure the performance of the system, AI systems, against the new data. Is it generalizing well? Is it performing as well as when it was during the training phase, training and test phase? So that's brings up the importance of the deployment phase, training board. So it's possible that if you're finding that in the case of Britain, the Alexa starts performing not as good as in Seattle, you may need to do a further study, find out a postmortem analysis. Let's assume you find out the accent, the Alexa system is not able to recognize some words or idiomatic usage of some words. You'll have to give it more data, retrain it, and do the same exercise, and probably again redeploy it. So this is just to give it some intuition about, are all the things we looked at in the first slides, are they relevant? Yes, definitely they're relevant. So this is like just to summarize what is encountered in a machine learning project. This is a very intuitive explanation about, and in the case of a speech processing example. Now, you can let me know how much time you have. I'll switch on to some other data related aspects, but I have many more slides. So if you're facing a time crunch, please let me know. So, okay, now we have all along talked about data. Okay, data is the oil, as they call it. I think HBR or Harvard Business Review somewhere, somebody mentioned HBR is a new oil. That means a metaphor for the oil, crude oil, which runs the industries, right? Data is the new oil, is it? And so here, let me give you a beautiful example here. So you have a Boeing 787, the aircraft, correct? So nowadays you have huge amount of instrumentation. Almost every aspect of the airline's functions, mechanical function, electronic sensors, you name it, instrumentation, signals, mechanical systems, electrical subsystems, electronics, navigation systems, your controls in terms of all your control surfaces, your turbine, you name it. There are instruments, devices which are measuring RPM, pressure, temperature, height, all of it is being measured. Okay, so what is it? It is a classical example where you absolutely cannot afford a malfunction, correct? You need to make sure that your prime factor, while profitability is important, your prime factor as per the regulatory authority is safety. Safety is a prime concern. So you need to make sure you have to absolutely no compromise with their safety. So that's this airline industry, especially the plane, is highly instrumented. And so you have, like the 787 example, there's every flight, you have a terabyte. And what is a terabyte? You have also, possibly all of you have heard about gigabytes, megabytes, gigabytes. 1,000 gigabytes is a terabyte. So here, please look at it. Every time you fly, you're getting half a terabyte of data, just one flight. Okay, so now look at it. So essentially, you do not have the luxury of coming back to your lab, downloading the data, taking a look at it, And for finding insight, you need to have the capability to have real-time, what is called edge or in situ processing. Edge or on the edge at where it happens. So let's say a plane is flying at 40,000 feet. The data is all getting generated, streamed. I need to have a mechanism for streaming, gathering the data, finding a real-time analytics on that, and flagging off any alarms, errors, etc., both to the plane as well as the ground station and your operations, HQ. So here, that gives you a classic example. The other types are, I talked about the airline industry, transportation. You have other examples of environmental monitoring. You have weather stations. You have, so many all over the world, wind station, wind, weather, temperature sensors, pollution monitoring, etc. Machine health, I already talked to you with some examples, like things like instrument machines, smart metering. Smart meter, especially as you know, in India, I think it's just taking off in some places where you have not the old model meters, the electricity meters. You can have smart meters with have capability of both recording as well as context awareness, and also to and fro. You can perform actions on it. You can actually controls, and you can signal, etc. Communication capabilities there. Smart meters, activity tracking, all these Fitbits, and you can track. There are people who are very health conscious. You want to track your activity. You can actually have all this. That's an example of activity tracking. So here you're seeing the trend, which is actually moving on to real time. Everybody wants real time data and scalable real time and with good performance. So essentially one aspect, so as I said, the big data is generated by, one is the people as such generate big data, then others organizations, then you have the social media and all these things, all this generate data. So they generate typically, as I talked to you about, unstructured data, which is the biggest challenge. Structured data is relatively more easy to manage. So we'll just gloss over it. So these are some of the examples of Facebook, YouTube, etc. You have structured data, repositories of structured data, huge quantities of them as well. Twitter, emails is text data, Twitter feeds, YouTube videos, Facebook images and maybe text, blogs and all these things, documents, text, images, search, etc. And probably photos and other things. And this is an example. This gives you some example of this is probably not the most recent data, but eBay, the auctioning and other site, marketplace and auctioning and all those sites where you have used to handle about 100 petabytes of data. In the fourth column, you'll see 1,000 terabytes is equal to 1 petabyte. So you can just see the volume. Google itself, at some time back, 100 petabytes of data it used with processing daily. Primarily indexing search. Search is one of the biggest. YouTube, which is their subsidiary company, also generates a lot of data. But search is a single biggest repository of huge amount of data. Indexing, the index. Facebook, 30 plus petabytes of data. Spotify, 34 terabytes. Twitter, say 100 terabytes. So just a small insight into, a typical example. Let's say you have a Walmart or some company, in this case, a tools company, right? You have, let's say, a sales receipt, which is coming out. A typical format is something like this. So you have all these things are all structured part, the totals, the name of the company, the date, those all are coming up. They're structured because there is some field or something, and it's a printout. So this is some example of structured data, which is used in the enterprise. Here, all the other things I talked to you about, YouTube and Facebook and all this, is mostly unstructured data. So that's a big challenge. So here, you might want to know, one of the ways of defining, categorizing big data is what is called velocity. Velocity is how fast is the data getting generated and streamed. So Twitter is, it's a little small, I hope you can see it, 100,000 tweets every second. Okay, photos. Let's just see the volume of the, volume of the data. Somebody's trying to communicate with me, I think. One moment. Okay, yeah, okay. So just let me know when we are running out of time. I have many more slides, so I can, depending on the time constraints, I can stop when you want for the Q&A. Okay, so these are some of the examples of the velocity. There is something called the 3 V's: velocity, variety, volume. Volume is the size, velocity is the speed at which, variety is the types of data, structured, unstructured, with an unstructured text, image, etc., etc. Then of course, here there's just a simple trick question, like we're talking Twitter data, 12 terabytes per day. How much of Twitter? So people typically use it for sentimental. One of the key things people use is sentiment analysis. If you launch a product or a service, or let's say simple thing like next an election, a candidate standing, how popular is a candidate? Is he a popular? People do surveys, right? When you look at the US elections, how popular they do polls, Gallup polls. Is the candidate popular? If they find the popularity getting down, they have to take action to kind of bump it up again. So the sentiment analysis is very important in today's world. It can also extend to, as I call, products and services. 1 minute, just a minute. Okay, yeah. So it's a very important factor to have sentiment, doing the sentimental and getting a pulse check of your customers' sentiment around a product service. Oh no, it's again hanging now. Okay, I think system is hanging. So I'll take in a good 1 minute. I'll just Srikala, you can just step in just a moment.
Yes, sir. Yes, sir.
I think it's. Are we running out of time, or I think we have reached 1 o'clock, right? So I think if you want, I have many more slides. I can go on for another 1 or 2 hours. So, so you can let me know, because I'm facing an issue with the display. So it's not. Okay.
Sir, actually, we are a little running out of time. So you may please conclude with your next applications, and we may proceed it in the upcoming webinars.
Okay. Anyway, I think it's maybe the system has told me it's time to stop because my display is frozen over. So I'll take any Q&A because I'm not able to advance my slides. Apologies for that. There's some issue here. So I'm willing to take any questions that you have.
Okay.
Participants have any questions? Yeah.
So all the participants, do you have any questions? You may please post it so sir could answer to it. Yeah.
Hello, sir. We have a student, a person who has posted a question. So he wants to know, this is from Rahul, he wants to know the difference between data science and data analytics.
Yeah, data science and data analytics. Yeah, data analytics, as we know, is if you can just interpret the etymology of the words itself, you're actually doing analytics on the data. So data science also, you're pretty much, as I said, as I defined, you're trying to draw insights from the data, correct? I gave an example of machine learning as an application. The consummation of a machine learning project is you have an application which is running as a mobile app or a web app, okay? And you can actually physically do, I gave you examples of house price predictions or image, image, you want to matching an image, etc. These are examples of running machine learning applications. Whereas a data science, I gave you an example is like, I showed you an example, same from the house price prediction example, you gather insights. When I said that, given the same square feet size, one of the insights gained is you find from the data, you can infer that if you have more, all other things being equal, if you have more number of bedrooms, maybe the size, maybe the cost of the house is going to be more. Or another inference would be all other things being equal. If I have a newly renovated house, it could probably sell at a higher price than a older house. So these are all insights, and typically, and so how do you present it? See, analytics has two things. One is the process you do, all these, preparing the data and stuff like that, and writing your finding. And second is also what is called visualization. So what you do is you have to visualize using popular tools like R or Tableau, etc. You visualize, you present your findings, you analyze your findings, give your story, and you give your findings, and you present your case. Let's say you're giving your management a presentation on what things need to be done to improve the sales of a product. So you will look at the, maybe the advertising budget has to go up. So you analyze the data, you look at the customer interactions with your products and services, and after so many things, you find that, let's assume one of the insights you're getting is that you need to reach out more to the customers. You need to have marketing, and you need to launch some ads and have a marketing campaign. So, okay, that's an insight. So you would actually put it in your report or your study or your PPT, and you will show it. So that's also an example. You're actually using data, analyzing the data, performing data analytics, using statistical tools or hypothesis testing and stuff like that, and you're presenting the data. So data science also involves, it's a nomenclature use, but you use many other data analytic techniques to arrive at your insights and your presentations.
Thank you, sir. I hope that answers your question, Rahul. So there's one more question. So we saw this how AI consolidates all the data and gives you, with one answer. So does it also predict incidences? Like, for example, we had a housing estate crash in US, which the economists could predict. But how about AI?
Okay, okay, good. No, that's an excellent question. So, yeah, definitely, most definitely. I'll tell you why. You have I think, what is the year? I think it was whatever, Fannie Mae, Freddie Mac, and then housing crisis in the US. And obviously, housing crisis didn't happen by accident, correct? You had a lot of levered loans. You have what is called toxic assets being created. The financial services industry was in turmoil. All kinds of regulations were bypassed, and you had toxic assets were being sold. Regulatory frameworks were disregarded. All this was known. People who are actually looking at the trends, industry trends, were aware of it far before. No, Raghuram Rajan has written a book called Fault Lines. Okay, so essentially, before the event actually happened, there was a lot of history. The moment the markets go into a turmoil, where all your salient, what I call sensible measures are disregarded, and it goes into what is called what Alan Greenspan called what is that word he used? Not on speculation, irrational exuberance. He used the term irrational exuberance. So the markets were frothy. The safety consideration, the rating agencies' recommendations were disregarded. The whole industry was happy because they were making a lot of profits. But if you were a financial services analyst there, you would have known far before what happened, a crash is coming. So coming to your point, if I was analyzing the amount of sale of these subpar instruments and subpar mortgage instruments, and the profile of the customers who were giving loans, typically, let's talk about an example. Like when you approach a loan, a company or a bank or a housing finance company or a consumer finance company for a loan, there are a set of processes you have to follow. They'll ask you your demographic data, probably your pay slip, your salary information, your occupation, age, gender, demographics, so on and so forth. And from that, they have a model which allows them to give the yes, no, or hold decision based on your profile, your past payment history. They can actually sanction your loan. In some cases, reject. Some case, people who have a bad track record, bad credit bureau history, they can reject the loan. So using all these factors, if you have actually built a model, taking care of your credit history, past history, payment thing, geopolitical events, and the size of the market, the volatility of the thing, the quality of the instruments being traded, etc., most definitely I could have found out that there is a crisis point approaching, and I could have, if I was running the system, I would have told my investors, stop now, there's going to be a crash. I could have most definitely I could have done the prediction. This is like a cause-effect relationship. Before the actual catastrophe happened, there were so many indicators which actually contributed to that. So if you had a model with some thresholds, etc., I could most definitely have written a model to predict that. Did I answer your question?
Yes, sir. Thank you. So one more question. On your biography, it's written as the cognitive business division you're in charge of. So what does that mean, cognitive?
Okay, so this was my tenure at IBM. As I mentioned to you, I gave some examples of the IBM Watson cognitive system. So I also gave you an example, indirect example, that you had this Jeopardy, the program, as well as a chess example, correct? So what happened is, I also gave you some factoids about the proliferation of data happening, and primarily the vast majority of data, which is called some people call it dark data, unstructured data, etc., etc. So the reason being that structured data is far more easier to process. Like you're talking about, let's say typically what happens in Oracle database or a SQL Server database, which comes as form of structured data, tables in databases, RDBM systems. So these are called structured data, for which you can actually interpret the data and find out reports. In the case of unstructured data, it's not like that. It's a very different ball game. You may have text, images, and in the example of the Jeopardy example, question answering service. Somebody asks you a question, you can figure out the answer. So just imagine what it is. So now coming back, I won't take a very long time. You need to, behind every question, there is an intent. The person asking the question needs to find out, he's asking you something. He has an intent. He wants to know, he or she wants to know answer to something. So the system has to comprehend the question, dissect what are its elemental entities in the question, and finally it boils down to intelligent search in the background. So the system has what is called a corpus of knowledge. So here in this case, Watson is expert, has a lot of capabilities. It has huge concept, all the encyclopedias, all the published literature. Let's assume your question was about COVID. It would have all the John Hopkins universities and all the things, corpuses, medical community, all corpus sitting inside Watson. This question about COVID, let's say somebody says, I have a temperature of 100 and whatever, 102 degrees centigrade. Do I have COVID? Okay. So this guy, this Watson has to figure out from the question, what is it you're asking? You're asking whether you have COVID. What are the symptoms you're showing? I'm having a temperature. It needs to, like a human being, it needs to understand the intent of your question. And it has to, a lot of intelligent processing analysis it has to do. And from its huge corpus of knowledge it has in the background, it has to fetch your answers and give it to you. So this is the platform called Watson. Google and others also have platforms. So Watson is the division, is I would say the crown jewel of IBM is a cognitive. Cognitive by meaning it has an intelligent system, which is like mimics the human being in its thinking. So it's a cognitive system. So in IBM there is the cognitive divisions, cognitive business division. We used to do consulting and solutioning around that, and it is part of what is called a global business services of IBM. I hope I answered your question.
Yes, sir. Thank you. And final. So this AI is the future power. That's what is being said. So you agree with it?
Well, I would like to think there are many powers, not just AI alone. And by the way, what is probably a little is artificial. Maybe more. NI also needs to develop natural intelligence. Also, that's also very important. Okay, now let me come to your point. See, what's happening is there's a lot of hype, no doubt about it. After seeing movies like Terminator and I think Oblivion, and there was another report, a Tom Cruise movie called Minority Report. All this deals with themes centered around AI. Okay, so what happens is people have actually seeing all this and then there's another movie called AI Robot, Will Smith and others. So there's a lot of people have seen a lot of futuristic science fiction movies and have come to the conclusion that AI is going to take over all the world, and a lot of negative also. People are talking about robots and systems taking over the world, and at some point even subjugating human beings. So if you come back, if you remember, I had shown you a slide in the beginning where I talked about artificial narrow intelligence and artificial general intelligence, correct? Most of the breakthroughs and things are happening is natural intelligence, speech processing, image recognition, driverless cars, those kind of systems have made a lot of progress, and in some cases have actually mimicking or exceeded the capabilities of human beings to predict or match or classify as a situation may be. The right side, which is called general intelligence, is where systems such a lot of work needs to be done for machines to actually come on par with human beings. Things like simple things like, if it's simple computation, maybe a machine is probably streets ahead. I mean, it's a raw computation. But things like empathy, emotions, sentiments, and real life experiential learning, like human beings talk about experiential learning. So all of us know that when we are children and when we grow up in life, there's so many things you learn from your experience, and uniquely each person's experience is probably different from another person. Okay, so these are things which are very, very difficult for machines, even AI systems, to learn. Okay, it'll take a lot of research, and a lot more research will happen. Maybe 100 years before AI would probably be able to match humans in the right side of the what I call general intelligence. A lot more. Obviously, fact that computing and capabilities and algorithm developing is no doubt thing, but to actually on these latter half, not just raw computing, but on the latter half capabilities, AI will still, to actually reach what I call a pinnacle of NI, natural intelligence, will still take a long time. I hope I've answered your question.
Yes, sir. No, go ahead.
Yeah,
Sita.
so with this we'll close, sir, actually. So out of curiosity, just to switch to this topic, I'm asking, this is out of curiosity only. Sir, we have this auto speech to text converters, right? So I have seen, just out of my curiosity, okay? So I have seen that in different languages, no? Only still now it is like giving 100% accuracy only if you speak in English, UK or American accent. So in the nearby years, will AI reshape this kind of like, since you were talking about the sentiment analysis and all those, no? So will it be able to kind of like predict and give us 100% accuracy on this?
See, I wouldn't want to hazard 100% accuracy. What I'm saying, it'll keep improving. Definitely, I can say that because I give you the example of that machine learning, the steps, right? I showed you an example of Alexa, and I showed you,
Yes,
I
yes.
gave you a case, this thing where, let's say, you initially built the solution, deployed in the US, and then you deployed in a different geography, and you found that maybe the performance of the AI system was not as much as what you, as the local or base language in which it was actually trained and deployed. I gave you that example, kind of intuition.
Yeah.
So now, see, speech processing again is a lot of work, and I think much work has been done on the linguistics aspects and speech processing and the intuition behind it and understanding and all this.
So, sir,
The grammars and all that. So that in English, obviously, they have got a head start over other languages
yeah.
because most of the Silicon Valley and other and the universities which were initially doing research were all in the United States.
Yeah.
Of course, there are also European universities doing, I think, doing a lot of fair good work in Germany and France and other countries doing a lot of fair. And I would imagine they have their maybe proprietary or other, built solutions which are probably very accurate, which may not be freely available, like the systems built, freely available, public open source ones. But it will improve over time because what is improvement? For improvement to happen, multiple things to happen. One is the algorithms and the quality of the algorithms, because the model, as I said, is possibly biased towards the English language. There is a term called bias, correct?
Yeah.
Bias is not like in when we talk about the idiomatic use of bias. Bias, I'm saying that it is heavily, the training is heavily weighted towards the factors which have gone into training is more heavily weighted towards the constructs in the English language speaking countries. Okay, so so maybe what we need to do, as you said, to improve performance in non-English speaking countries is that you need to develop models which are more, I would say, which are you said speech to language conversion is what you said, right? That is your audio and then language. You said when I convert to English, I get almost 100% accuracy. When I convert to, let's say, Malayalam, or Hindi, or Tamil, or Kannada, I probably don't get that level of accuracy. So all I'm saying is, maybe what you need to do is that you need to build models. If you see that there was an overfitting or over bias towards English, correct that in favor of these languages using the grammatic and linguistic aspects of that language, maybe Hindi or Tamil or Kannada or Tamil, and use those aspects in the training so that it becomes better training and you get better trained models and which have better performance characteristics.
Okay, sir. Sir, we have a question from Mr. Akshay Bhatt. He's asking, is AI just a software or is it incomplete without hardware?
Okay, that question is actually to some extent, and some extent I touched upon in that AI versus, ML versus data science, correct? So an ML software, AI, after which the biggest tools, method uses ML is by far the biggest ML. Okay, so machine learning. When we say that, how is it? What is the outcome? The outcome of a machine learning project is a software which is running on some kind of computing device. It could be a laptop, it could be a server, it could be a mobile phone, it could be an embedded device. It is some software running there, which is running possibly 24/7, which is getting the data, ingesting it, learning, and predicting or doing something, taking some actions. So it's essentially a program which is running on some kind of computing device. Need not be a computer in the conventional sense of understanding. It could be an embedded device, it could be a machine, it could be a Fitbit device, it could be an automotive device, it could be a laptop, it could be a server. But ultimately, it's some kind of a program. It could be a binary, machine learning thing. It could be a Python program or whatever. It could be in some form, in some bytecode or in some binary code running.
Okay, sir. One more doubt from Mr. Samson Matthew. I have a small doubt. Say before 30 years, we could never imagine what will be have now, like say smart mobile phones or the computer systems. Similarly, will we really need 100 years for AI to mimic a human intelligence in a good way?
Okay, see that question is, as I said, see the easy part of it is there is rapid progress happening in the easy aspect, which is what I call the artificial natural intelligence. That is typical, things like speech processing, driverless car. There rapid progress is happening. Correct, rapid progressing, medical diagnosis, genome sequencing, rapid progress is happening. But as I said, getting the human-like natural intelligence aspects, where you get a machine to physically, to mimic a human in the real sense of the word, that is a far more difficult problem. Okay, 100% is just a metaphor. It may be 100, it may be less than that, maybe 20 years. But that's a far more difficult problem to crack than the problem set happening under the basket, what I call ANI, where you have typically an engineering or a technical solution to real world problems. So that there rapid progress is happening. As we speak, a lot of new solutions are coming up, and rapid progress will happen in the ANI basket, artificial narrow intelligence basket. The artificial general intelligence basket is much more, I would say, a difficult, which requires much more research. That may take more time. It may be decades, maybe you may have breakthroughs. It all depends on the research community who are doing work. A lot of work is going on in that area. But the part of the AI which is visible is the left-hand side, which is the artificial narrow intelligence. That is where you are seeing all your mobile phones, smartphones, your apps coming. All that is concentrated on the left part of it.
So, okay, sir. So I think we are like little running out of time. So, sir, so shall we close, sir? So, yeah, we'll proceed in the future webinars. Yeah.
Yeah, and if participants have any questions, please let them feel free to get in touch with us. We can send them, respond to them. Thank you very much. Thank you. I hope you liked it.
Yes. So, Shirpa, can you give a vote of thanks, please?
Yes. Thanks, Srikala. Thanks so much, Dr. Venugopal. This was quite informative. You went non-stop for almost 2 hours without any break. Thank you, sir. And also, I would like to thank my team, Sadanand, who was behind, all this webinar. And thanks, Srikala. Thank you so much. And thank you everyone for participating. Please keep your questions in the text box. We will answer each and every question.